Hi folks, we're going to take a look at number 6 from page 225. So they tell us that cotangent of 4 pi over 9 is going to be equal to tangent of z, and they want us to determine a measure for z. Now in the actual question, they're very specific about how they want you to solve the problem, but I'm actually going to find two possible values for z just to see that we've got other options here. In fact, I would expect there to be infinitely many solutions, but we'll take a look at two of them. So as soon as you see an equality of trig ratios that are not the same, okay, you really should be thinking about your correlated angles. Okay, so in particular, I've got cotangent equaling tangent. Okay, so let's try to figure out what our what angles we should be working with. So let's just recall here. So if I've got some angle in the first quadrant here, so theta, okay, I'll use this as my guide. All right, I know that for cotangent and tangents to be equal and not negatives of each other, well, they have to have positive signs in those quadrants. So I'm going to have one possibility in the first quadrant, okay, which is going to be pi over 2 minus theta, and then I'm going to have the possibility in the third quadrant, where cotangent is also positive. So here, this is going to be, well, it's 3 pi over 2 minus theta, because remember now we're working with the correlated acute angle, so from the y-axis. So the other option is going to be 3 pi over 2 minus theta. All right, and let's recall what our identities say, telling us that cotangent of, not cosine, but cotangent of 3 pi over 2 minus theta has to be equal to tan of theta. So this will be our first, actually this will be the second one we'll use. The first one we'll use will be that cotangent of pi over 2 minus theta is also equal to tan theta. Okay, so let's start with this one here. So that means my 4 pi over 9 needs to be equal to pi over 2 minus theta. So we have 4 pi over 9 is going to be equal to pi over 2 minus theta. But what is theta equal to? That's the one inside the tangent, so that's going to be my z. So that means that 4 pi over 9 has to be equal to pi over 2 minus z, and now I can just solve for z. Okay, so let's bring the z to the other side, make it positive. So here we have pi over 2 minus 4 pi over 9. I'll just put everything under 18 right off the bat. So here this is going to be 9 pi over 18 minus 4 times 2, 8 pi over 18. So z is going to be equal to pi over 18. Okay, so that's one of the values that z could be equal to. All right, so just to recap, what I did is I realized I had a cotangent equal to a tangent, so I tried to determine what correlated angle identities fit the bill here, where I have a cotangent value equal to a tangent value, and it was working with pi over 2 minus theta. So I just made these associations. 4 pi over 9 becomes my pi over 2 minus theta, and z becomes my theta, and I was able to get an equation. So that's just a second one, just so that we see that we can get a second value here. I'll use this relationship now. So now my 4 pi over 9 needs to be equal to 3 pi over 2 minus theta. So 4 pi over 9 is equal to 3 pi over 2 minus, but again, theta is just going to be that z angle given inside the tangent in the equation we're working with. So this is going to be minus z. So now I can solve this equation again, bring z to the other side. So I'll put everything over 18 again. So 2 times 9, 3 times 9, 27 pi over 18 minus, and this is going to be again over 18, it's going to be 8 pi over 18, and so z can also be equal to 27 minus 8 is 19 pi over 18. So there's another possible value for z. Okay, so again, to recap, realize that you're going to have to work with a cofunction identity or correlated angle identity, and then determine what angles you can possibly work with, and you'll look at that based on the sign and the type of trig ratio you're working with. So because they're both positive, it means you can always work with the pi over 2 minus theta angle. But because we're working with cotangent and tangent, our other option was to work in the third quadrant where cotangent is positive. Okay, that's it for this one.